This is my trigonometry course. Today we're going to cover a few more things that we didn't have a chance to learn in previous parts of the course. So we're just tying up loose ends. These are things that I didn't cover because I didn't want to complicate the previous material, and we have an eclectic list here. If you want to see what we're going to do, you can look over that. So let's start with using a calculator to evaluate cosecant, secant, and cotangent functions. Now, we use the calculator to find the value of expressions like this when the angle was not a special angle like 30, 60, 45, 90, 120, so on and so forth. But in those situations, we always had a sine, cosine, or tangent function. Now we have a cosecant function. Now, how is that different? Well, it's a problem because you may notice on your TI calculator, you don't have this function on that calculator. You don't have a button for that function. Same with the secant function and the cotangent functions. There is no button. And if you look at your iPhone, if you're using an iPhone or even an Android phone, they don't have these. They don't have buttons for these functions either. Now, there are some graphing calculators that do have these functions programmed, but you may have to bring up a screen on the actual calculator. It may be buried somewhere in the calculator, but it may be difficult to find. So how do we do this? How do we calculate cosecant 73 degrees when the calculator doesn't have a button? Well, it's very easy. We just use a reciprocal function. So we just convert that to 1 over sine 73 degrees. Remember, cosecant theta is the same thing as 1 over sine theta. So now we go to the calculator and we enter 1 divided by sine 73 and then enter. And we get approximately 1.046, and we're rounding to the nearest thousandths. Alright, so same with the secant function. We're just going to change that to cosine 35, or 1 over cosine 35 degrees. 1 divided by cosine 35, enter in our calculator, and we get 1.221. And that should be approximately equal to. Now, if you're using an iPhone, you want to enter 1 divided by, and then 73, and then the sign button, and then equals. 1 divided by 35, and then the cosine button, and then equals. So it's different depending on what calculator you're using. So with cotangent, we're going to do the same thing. We're going to just use a reciprocal identity. And 1 divided by tangent 217, enter, and we get approximately 1.327. So there you go. So this kind of demonstrates why the calculators do not have these functions programmed in, because why would you even need them? You can just use a reciprocal identity. So the engineers just decided not to put those functions on the calculators. Now again, you may be able to find the function somewhere in your calculator, but it's not going to be easy. And I don't believe that the TI-84 Plus, the most popular graphing calculator, has those functions programmed in. I haven't really done a lot of research, but I can't find it based on just a quick look. But anyway, go ahead and try number 4, and when you come back, we'll do it together. Okay, we're back. So we're going to convert. And if we enter that into our calculator, 1 divided by sine 125, enter, is 1.221. So if we got that right, perfect. Go ahead and try number 5, and when you come back, we'll do it together. All right, we're back. So secant is 1 over cosine. And we can use a calculator. 1 divided by cosine 149, enter, and we get negative 1.167. So rounding to the nearest thousandth. So if you got that right, good job. Go ahead and try number 6, and when you come back, we'll do it together. Okay, we're back. So cotangent is 1 over tangent. And we can use a calculator. 1 divided by tangent 39, enter, and we get approximately 1.235. So if you got that right, perfect. So as you can see, it's pretty easy to deal with that problem. Again, your calculator does not have these functions, most likely. So you have to know how to calculate those values without a button programmed into your computer or your calculator. Okay, so that's the first thing that we covered on the list. So we're done with that. The first thing that on the list. So now we're going to move to equations. So in the previous problems, we were trying to find this ratio here. We're trying to find that given the angle theta. But in these problems, we're given the ratio and we're asked to find theta. So we're going in the backwards direction. Now, we don't recognize this ratio. It's not 1/2. It's not root 3 over 2. It's not 1 over root 2. It's not 1. It's not -1. It's not 0. So we have to use a calculator. So all we have to do is enter this into our calculator, and then we've got it. The problem is this is not in your calculator. So we're stuck. We can't do it. But a way to avoid this is we can use, again, a reciprocal identity. Isn't it true that cosecant theta is equal to 1 over sine theta? So I'm now going to use basic algebra. I'm going to multiply both sides by sine theta. The sine thetas cancel out on this side, and we're left with 1 is equal to 5 times sine theta. I'm then going to divide both sides of the equation by 5, and we get 1 over 5 is equal to sine theta. So I did a lot of work there just to show that sine theta is equal to 1/5 if cosecant theta is equal to 5. Now, I want you to understand that you don't have to show any of this. As time goes by, you're going to realize that if you know the cosecant ratio, or the ratio that the cosecant theta is equal to, then the sine of that same angle is just going to be the reciprocal of that. So you just flip over 5. If you have 5 over 1, it flips to 1 over 5. If secant is equal to something over something, then you just flip it to find cosine, and back and forth, back and forth. So again, you don't have to show any of this. But students do get kind of confused, so we're going to show how to do that in the first couple problems. So what is the point? Why do we do that? Well, again, in order to find this angle, we'd have to use the cosecant inverse button on our calculator, but we don't have that button. But we do have a sine inverse button. Theta is equal to sine inverse of 1/5. So the theta that you see here is the same theta that you see up there. It's just in a different equation. So now we can go to the calculator. So if you're using a TI-84 plus, press the blue button at the upper left, then the sign button, and then 1 divided by 5, and then enter. And we get 11.5, and it says, well, it doesn't say what to round off to. So we can just say 11.537 degrees. And it wants the answers, all the answers between 0 and 360. So let's draw our triangle. We have a triangle in the first quadrant, but when sine is positive, you're going to have a triangle in the second quadrant also. And the reference angle is 11.537 degrees. So that's going to be the reference angle in both triangles. So one answer is 11.537, and another answer is whatever that red angle is, and maybe I'll make that a different color. And in order to find that, we subtract 11.537 from 180. And you can use the answer button, push the blue button at the upper left and the negative symbol with parentheses at the bottom right, the answer button, to find that number, and it's going to be 168.463 degrees approximately. So we have our two solutions. Theta is approximately equal to 11.537 degrees and 168.463 degrees. So again, we had to use our calculator, but we don't have a cosecant inverse button. See this cosecant inverse 5, we don't have that button. So we had to change it to an equation involving the sine function. And then we found theta because we do have a sine inverse button in our calculator. This seems like kind of a small thing, you know, just a little detail. And the reason that we didn't cover this in the previous parts of the course is I just didn't want to complicate things. So I gave you problems where you only had to use a calculator when you had a sine, cosine, or tangent function. So let's try a number 8. So we're going to solve this equation, and we have to isolate the trigonometric function. It's not isolated because the 11 and the 5 are next to it. We have to get those out of the way. So I'm going to subtract 5 from both sides. And I'm going to divide both sides by 11. And we want to find the angle. This is not a recognizable ratio, but we don't have a cotangent inverse function in our calculator. We don't have that, so we can't do it. So what we can do is change cotangent to 1 over tangent omega. We do have a tangent inverse function in our calculator. So again, you can just flip. If cotangent is equal to negative 8 over 11, then tangent is going to be equal to negative 11 over 8. You just flip this. But again, students sometimes get confused by that. So we're going to show all of the steps. So I'm going to multiply both sides of the equation by tangent omega. And that's going to cancel out the fraction, and that's the main purpose for doing that. And we're going to be left with negative 8 over 11 times tangent omega is equal to 1. Then I'm going to rewrite, and I'm going to divide both sides of the equation. by negative 8 over 11, and this is not the fastest way to do this problem, but algebraically this is the easiest way to understand it. So when you do that, these are going to cancel out, and you get a complex fraction, which is very complicated to deal with. Many different ways to simplify this. When students see complex fractions, they tend to become very confused, but you should know how to deal with these at this level of mathematics. If you don't, then you can join the club of most students. They don't really know how to deal with that. There's many different ways to do it, but the fastest way to do it is to simply multiply both sides of the fraction by 11. We can multiply the numerator and the denominator of a fraction by the same number, and the fraction value does not change. If you do that, these 11s cancel out, and you're left with 1 times 11 is 11, and negative 8 11ths times 11 is negative 8. So we did all of that just to show that tangent omega is the reciprocal of this. So, or the reciprocal of this up here. If cotangent is equal to negative 8 over 11, then tangent is equal to negative 11 over 8. We just flip it. So again, I want to make it clear, you don't have to show any of this work. And this is going to be the last problem where I'm going to show that work, because it just gets boring and tedious to have to constantly show that over and over again. So if you want to see that, you can go back to these problems. So let's review the point of what we did. We want to find omega, but we can't because our calculator doesn't have a cotangent inverse button. But our calculator does have a tangent inverse button. So now we can find omega. So in my TI, I'm going to press the blue button and then the tan button, and then I'm going to enter negative at the bottom right, the negative symbol with parentheses, 11 divided by 8, and then enter. And notice that we actually get a negative angle. So negative 53.9726 degrees. Now we're supposed to find the answers between 0 and 360. Negative 53 is not between 0 and 360. So this number is the reference angle, but it's not one of the actual angles that we're looking for. So let's look at this tangent equation here. Tangent is negative. So if it's negative, then that means that the reference triangles have to be in the second quadrant and the fourth quadrant. And the reference angles are all 53.97. We can just round off to 53.97. And let's find the actual angles. Here's one angle there. So if we subtract that angle from 180, we get the red angle. And if we subtract 53.97 from 360, then we get the next angle. So I'm going to make that blue. So that blue angle is, let's calculate that. We get 306. 306.027 degrees. So theta, or excuse me, omega is approximately equal to 126.027 degrees and 306.027 0.027 degrees, approximately. So again, our calculators cannot find the angle inside a cotangent function within an equation because our calculators just don't have a cotangent inverse button. Okay, so you can get a picture of these with your phone if you'd like. We're going to do one more of these. Now notice that it wants us to find the measure of the angle between 0 and 2 pi. This implies that we need to write our answer in radian units. Now you can change your calculator mode to radian units, but it's not as easy to analyze radian units as it is with degrees. So instead of changing our calculator mode, we're just going to find the answer in degrees and then use our conversion factors to convert to radian units at the very end. So let's subtract 7 secant alpha from both sides. And add 31 to both sides. And then we're going to divide both sides by 3. Now, we want to use our calculators to find the angle using a secant inverse function. This is what we enter into the calculator if we want to find alpha, because this ratio is not something that we really recognize. The problem is our calculator doesn't have a secant inverse button, so we just can't do that. So we have to convert this equation to something involving the cosine alpha function instead of the secant alpha function. Now we could show all the algebra, but that gets really tedious, and you don't have to do that. You can just flip the ratio. If secant alpha is equal to 22 over 3, then cosine alpha must be equal to the reciprocal, 3 over 22. You don't really need to show the algebra for that. You need to get to the point where you can just flip these things quickly, understanding the relationships between the different trigonometric functions. So now we can use our calculators to find alpha, because we do have a cosine inverse button. So let's get our calculators out. The blue button, and then cosine button, and then 3 divided by 22 if you're using a TI-84 plus. We see alpha is approximately equal to 82.1625 degrees. And that's the first angle. Now notice that the calculator gave us our answer in degrees, but we want our answer in radians. Well, we're going to worry about that later. We could program the calculator to give us our answer in radians, but the problem is when you see the radian measure, it's going to be something that's kind of difficult to understand in terms of which quadrant the angle, the terminal side of the angle is going to stop in. So it's better to keep our answers in degree units for now. So we have 82.1625 degrees. We'll say that's about there. And cosine is positive in the first and fourth quadrants. So we have another triangle in the fourth quadrant. Let's put that triangle down there. And the reference angles are 82.1625 degrees, and down here again the reference angle is 82.1625 degrees, but over here the actual angle is 360 minus that number, which is 277.837 degrees. So our two answers are 82.1625 degrees and 277.837 degrees. Now I'm going to put little green dots because I want you to know that you need to keep those numbers in your calculator if you can. Now remember, we're looking for the answers in radian units because it says up here, find alpha between 0 and 2 pi. Up here it says that. Find alpha between 0 and 2 pi. So now that we've found the answers, we want to then convert to radian units. So we're going to multiply by pi radians over 180 degrees. And we're going to use the factor label method. So pi over 180 degrees, and notice that the degrees are going to cancel out. That's what we want. And we're going to be left with radian units. Now again, we could say pi rads over 180 degrees, but we don't really need to. That's not really necessary. I know that's strange, but we just don't need to. So I have my number here in the calculator, and I'm going to multiply. I'm going to say times, and then the blue button at the upper left, and then the upside down V button at the middle right. And that's going to multiply by pi, the actual number pi, and then enter. And then I'm going to say divided by 180, and then enter. And that's going to convert to radians. And again, you don't have to write radians. I know that's strange not to write the units, but you just don't have to. So with an iPhone, it's going to be a little bit more difficult to do this because you may not be able to recall your answers. But with the TI-84 Plus, you can use the arrow keys to go up and find where it says 82.1625. You can go up to your previous numbers in your calculator. Then highlight that number and then press enter. And what that'll do is it'll bring it down for you to use again. So that's pretty neat. So then do the same thing. Say times the blue button and then the upside down V button at the right. Enter. So that's times pi, and then divided by 180. And when we get 1.434 radians. So these are the two angle measures. Why did we have to write such weird angle measures? Well, because it tells us to use radians. So we had to do that. Now again, you can tell the calculator to find the measure, the radian measure, but the problem is it's very difficult to understand what 1.434 is when it comes to the X and Y axes and where the triangles are going to be, because we are familiar with degrees, but we're not really familiar with radian units. So it may be best to leave this conversion to the last step. Okay, so I want you to take pictures. If you haven't already done that, go ahead and take a picture of these two problems. And I want you to take a picture, well, you can just use number 9 to help you do 10. So go ahead and try number 10, and when you come back, we'll do it together. We need to use our calculator to find beta. The problem is we don't have a cotangent inverse function, so we have to change this to an equation with the tangent function using the reciprocal identity. So go ahead and try number 10. When you come back, we'll do it together. Alright, we're back. So if cotangent is equal to 0.64, then tangent is equal to 1 over 0.64. If you want to write an extra step, you can. Cotangent is just the same thing as 1 over tangent. But then if you flip both sides of this equation using a shortcut algorithm, flipping both sides is really just a shortcut algorithm. We're not explaining the algebra because, again, that just gets too tedious. So 1 divided by 0.64 is 1.5625. So now we can use our calculators. We couldn't do it before, but now we can because we have a tangent inverse button. We didn't have a cotangent inverse button, but we have a tangent inverse button. And so I'm going to push the blue button at the upper left on my TI-84 Plus, then the tan button, and then 1.5625, and then enter. And B is approximately equal to 57.38, we'll just say 38 degrees. And it's probably best to keep that number in your calculator. So that is the reference angle. Tangent is positive in the first and third quadrants. How do I know that? Because you have adjacent, or opposite divided by adjacent. Positive divided by a positive is a positive. And over here you have negative divided by a negative is a positive. So let's draw that triangle here, and we can draw it over here. The reference angle for both these triangles is 57.38. So 57.38 degrees. You don't have to draw all of this, all these reference angles and things. We're just doing it so you can see what's happening. So if you want the red angle, we have to add 53.38 to 180. And I'm keeping that number in my calculator to avoid any round off error. So we have 237.38 degrees. And the first angle is this green 57.38 angle. So the good news is we don't have to convert to radians with this problem. It doesn't tell us to do that. So we have two solutions, 57.38 degrees and 237.38 degrees. And again, these problems are only asking us to find beta between 0 and 360, and that reminds me that it's not theta, it's beta. So I have to be careful about that. We're looking for beta. Looks like I made the same mistake in the previous problem. That's not theta, that's alpha. Sorry about that. Okay, so if you got that one right, good job. Okay, on to number 11. Go ahead and try number 11. Be aware that your calculator will not give you the reference angle. When the secant function is, or the cosine function is equal to a negative number, your calculator will not give you the reference angle, because cosine or secant, they're negative in the second or the third quadrants, which means that your answers are not going to be in the first quadrant or the fourth quadrant. So it's not going to be a negative number in the fourth quadrant or a positive number in the second quadrant. And if the answer is not in those quadrants, that means that it can't be an acute angle. It's got to be some sort of an obtuse angle. So you're going to have to deal with that. Try number 11, and when you come back, we'll do it together. Alright, we're back, so I'm going to subtract 3 from both sides to isolate the secant function, and I'm going to divide both sides by -8. And you don't really have to show the work, but if secant A is equal to -8, then cosine A is equal to -1/8. Again, that may sound weird, but it's just going to be second nature to you. So A is approximately equal to cosine inverse. Actually, it's exactly equal to cosine inverse of -1/8. So now we can go to the calculator. And notice that we want our solution in radians, so we're going to have to keep that in mind. So in the iPhone, you can rotate in landscape mode and press the second, or the first you want to enter you want to enter 1/8, and then push the plus/minus button, and then push the cosine -1 button. But you have to push the second button at the upper left to do that. Now I say cosine -1, but that's really not what it's called. It's cosine inverse cosine, or cosine inverse, however you want to say it. So we're going to push the blue button in our TI-84, and then the cosine button, and then the negative symbol at the bottom right, and then 1 divided by 8, and then enter. And again, we get a number that is not an acute angle, so it's actually not the reference angle. In this case, this is actually the angle, one of our angles. So the calculator actually gave us an angle that is one of our angles. So we're going to rotate all the way to there. So that is 97.18 degrees. But we have a solution in the third quadrant also. Cosine is negative in the third and second quadrants. But we can't find this angle unless we know the reference angle. To find the reference angle, we subtract 97.18 from 180. So 180 minus the blue button at the upper left, and then the negative symbol at the bottom right with parentheses around it, if you're using a TI-84 plus. And so 82.8192 is the reference angle. That's the angle in here. So maybe we should draw that. And I'm going to make this red. And our reference angles are usually green. So that angle is 82.819 degrees. So if we add that to 180, we'll get the angle that terminates in the third quadrant. So that'll be this angle here. So 82.8198 plus 180 equals 262.819 degrees. And those are not the solutions, because we have to convert to radians. Let's write those numbers. And if you can, you want to keep those numbers in your calculator. I've got this number down here in my calculator, so I'm just going to multiply by pi over 180 degrees. I'm going to do the same thing with this number to change to radians. So times the blue button and then the upside down V button at the right, enter, divided by 180, enter. And we get 4.58. 7. And now let's find the other solutions. So you should have that number still in your calculator. And we get 1.696 radians. And again, you don't have to write the rad abbreviation. You don't have to write units for radians. All right, so if you got those right, excellent. So we're going to have one more of these problems. Now you can just write your answers in degree units. So try number 12. When you come back, we'll do it together. Okay, we're back. So I'm going to subtract 7 cosecant b from both sides. I'm going to divide both sides by -8. And I would like to find b using my calculator, but we can't because we don't have a cosine inverse button. But if cosecant b is equal to 20/8, then that means that sine b, remember sine is the reciprocal of cosecant, so you just flip it over. It's that simple. Now before we do that, we probably should reduce. So that would be 10/4. 10/4, which is 5/2. All right, so then that becomes 2/5. Okay, so now we can use our calculator. So b is equal to sine inverse of 2/5. So we're going to push the blue button and then the sine button, and then 2 divided by 5, and then enter. And so b is approximately equal to 23.578 degrees. And we'll try to keep that number in our calculator. Now that's the reference angle. We want the angle measures between 0 and 360. Sine is positive in the first and second quadrants. So first quadrant and second quadrant. So the reference angles are both 23.5, I'll just round it to 5.8. The actual angle in the first quadrant, the measure is 23.58. But in the second quadrant, it's 180 minus that number, which is 156.42 degrees roughly. So our solutions, b is equal to 23.578 degrees and 156.4218 degrees. So if you got that one right, excellent. Okay. So now we're going to use a calculator to evaluate inverse cosecant, secant, and cotangent expressions. Let's do some review. In previous classes, we learned how to find the value of these types of expressions. And this problem tells us to find the value without a calculator. If we really wanted to, we could just enter this into the calculator, because this is the type of notation that we use when finding the angle on a calculator. And you know, in previous problems we had an equation. This would be the corresponding equation for this expression, and we were asked to find theta between 0 and 360, and oftentimes there are multiple solutions. In fact, there's an infinite number of solutions to this equation. But when you see an expression written on its own like this, and it's not an equation, it's just an expression, this is considered to be the output of a function, an inverse function. And remember, for every input that you insert in a function, you can only have one output. And that's why we have range restrictions. This is what the sine inverse curve looks like. But the problem is, if you put an input into the function, which would be a number on the x-axis, then you can see that we have multiple outputs. You're not allowed to have multiple outputs for a function, so we have to restrict the range, and we have to get rid of that that part of the graph. And for the sine inverse function, our range is restricted to numbers between -90 and 90 degrees. So we're only going to have one output. So to solve this, we need to first figure out what this even means, and I kind of alluded to its meaning previously, but we're going to set it equal to theta, and if this is true, by definition, mathematicians have decided that this must be true also, as I explained earlier. So converting from this equation to this equation shows us what this expression is asking us to do. That's why we kind of go backwards a step. And again, we could just enter this into the calculator and find the answer immediately, but that's the problem, is oftentimes you're asked to find the value of those expressions without a calculator. So we want to ask, well, what is the value of theta? Well, of course, you probably recognize 1/2 as a special ratio, and that's why we don't need a calculator. So the answer is 30 degrees or 150 degrees. If you're looking for theta values between 0 and 360 degrees. The problem is, again, we're only allowed one output for any given input. The input of the inverse function is 1/2 in this case, and the output would be either 30 degrees or 150 degrees, or we don't know exactly. So we have to look at our range restrictions, and again, the restrictions are the output of the function, which is y has to be between -90 and 90 degrees. And remember, because this is an inverse function, the input is going to be the ratio, or just some number between -1 and 1, and the output is going to be an angle measure. So it's the exact opposite because it's the inverse function. So the only answer that we can get between -90 and 90 is 30 degrees. So that said, we have our answer. And again, this is all just a review of things that we did in previous classes. So sine inverse of 1/2 is 30 degrees. So now we're going to find the value of sine inverse of 4/5, and you notice that 4/5 is not a special ratio. We don't recognize that ratio, and that's why we need to do this with a calculator. So for this problem, we can find the answer immediately. We don't really have to do any investigation. We can just enter that into the calculator. If you're using an iPhone, rotate to landscape mode, press the second button at the upper left, then enter 4 divided by 5 equals, and then press the sine -1 button, and you should have your answer if you're in the right angle mode. If you're using a TI-84 Plus, push the blue button at the upper left, then push the sine button, then 4 divided by 5, and then enter. And we get approximately 53.13 degrees. So there you go, that was easy. So sometimes you're asked to find the value of these expressions without a calculator. Sometimes you can just use the calculator. In fact, we have to use a calculator because we don't know the advanced mathematics required to determine that value. So let's do one more example problem. We're going to find the value of cosecant inverse -√2 without a calculator. So now, again, we're going to have a recognizable ratio. So let's set it equal to theta. The first thing we need to do is to figure out what this is even asking. If we don't know what it's asking, then obviously we can't figure out what the value is. So we set it equal to theta, and then we convert into a basic trigonometric equation. If this is true, then by definition, this must be true also. So now we can see this is just negative x root 2 over x. It's just a 45, 45, 90 degree triangle. And if cosecant theta is negative, then it must be, the angle must be in the third or fourth quadrants. So theta is going to be equal to 225 degrees or 315 degrees. So to demonstrate that, we can draw triangles, and again, these are not the actual solutions. These are just what we think are the solutions. So one angle will be here, that's 225, but we need to look at our range restrictions. Cosecant inverse has to be between negative 90 and 90, not including 0. So our solutions have to be between negative 90 and 90, and you can see that they're not. So these are just, these are not the solutions. There's another triangle in the fourth quadrant, 315 degrees, but again, that's not between negative 90 and 90. But remember, if the range is between negative 90 and 90, instead of rotating counterclockwise, we can actually rotate clockwise and find the angle negative 45 degrees. So that is actually the solution. It's a coterminal angle with 315 degrees. If you start rotating counterclockwise, you get to the same terminal side, but negative 45 is the angle measure that we're looking for. So theta is equal to negative 45 degrees, and therefore we can write our final answer. Cosecant inverse of negative root 2 is equal to negative 45 degrees. Okay, so that was just some review. And now we're going to have a special situation here where we're evaluating cosecant inverse, secant inverse, or cotangent inverse functions where we need to use a calculator. Now, in the case here, in the previous problem that we didn't need a calculator. We're examining the cases where you need a calculator to find the value of these expressions. Now, it's very important to understand that if this were a sine inverse, cosine inverse, or tangent inverse expression, it wouldn't be a problem. You could just enter it into your calculator and you'd be done, just like we did up here. Remember example number 2, we just entered it into our calculator and we were done. But there's a big problem, and this is the whole point of what we've been reviewing, is to set you up for these problems. Remember, your calculator most likely does not have a cosecant button, and therefore it does not have a cosecant inverse button either. So how do we do this? Well, we're going to do what we did in previous problems. We're going to convert to a different function. Now, you're probably going to say, well, wait a second, can't we just use the reciprocal identity? Cosecant inverse 5/2 is the same thing as 1 over sine inverse 5/2. Unfortunately, that is not correct. We have a reciprocal identity that tells us that the cosecant theta function is equal to 1 over sine theta, but we don't have any sine inverse or cosecant inverse reciprocal identity that tells us that cosecant inverse of some value is equal to 1 over sine inverse of some value. We just don't have that identity. So what we're going to do is we're going to set this expression equal to theta, and then we're going to convert to this equation here like we did in previous problems. And just like we did with previous problems, we're just going to convert to a sine function, and when you do that, you just flip. Cosecant is the reciprocal of sine, and secant is a reciprocal of cosine, and tangent is a reciprocal of cotangent, and vice versa. So now we can say, well, theta is equal to sine inverse of 2/5. This is the same theta that we had up here. We're just using a different function to help us. The difference is now we do have a sine inverse button in our calculator. That's the whole point of doing that. So I'm going to push the blue button and the sine button, and then 2 divided by 5, and then enter in my calculator. And I get 23.57, well, 23.578. So it tells us here to round to the nearest thousandth. So cosecant inverse of 5/2 is approximately equal to 23.578 degrees. So there you go. So again, this is all based on the idea that your calculator does not have these buttons, and so if you have to use a calculator to find these expressions, then you have to know how to work around the problem. So now we're going to find secant inverse -10. We're going to set it equal to theta. And you don't have to use theta. You can use any variable you want. You can use omega or beta or alpha or A or B. So remember, if secant theta is equal to -10, then cosine theta is equal to -1 over 10. That's the reciprocal identity. So now we can use a calculator. We couldn't use a calculator before because our calculator didn't have the secant inverse function programmed in. But it does have the cosine inverse function, so the blue button, the cosine button, -1 divided by 10, and then enter. And the negative button is at the bottom right with parentheses around it. So theta is approximately equal to 95.739 degrees. And if you look at the range restriction for the secant inverse function, you see the range is between 0 and 180 degrees. So our number 95 is within that range. And so let's write the final answer. Secant inverse of -10 is approximately equal to 95.739 degrees. So there you go. Okay, let's try one more of these. So again, we don't have a cotangent inverse button, so we have to change to a different function. Let's set cotangent inverse to cotangent inverse 3 to theta, and if that's true, by definition, cotangent theta must be equal to 3. Again, it's just a definition, it's something to memorize. If cotangent theta is equal to 3, then that means that tangent theta is equal to 1/3. Again, they're reciprocals. So now we have a tangent function, so we can find tangent inverse of 1/3. We have that button on our calculator. So I'm going to do that on my calculator. and I get 18.435 degrees. And if you look at the range restriction for the cotangent inverse function, you see it must be between 0 and 180 degrees. And so our answer is in that range. So cotangent 3 is approximately equal to 18.435 degrees. And there you go. Okay, so I want you to try number 16. Be aware that for number 16 your answer will be a negative number, so don't be alarmed by that. Because the angle is going to terminate in quadrant 4. Try number 16. When you come back, we'll do it together. Okay, we're back. So we're setting the expression equal to theta. By definition, cosecant theta is equal to -4 if that's true. And if cosecant theta is equal to -4, then sine theta is equal to -1/4. That's the reciprocal identity. And now we can use our calculators to find the value of theta, because our calculators have that function on them. And we get -14.478 degrees. And for the final solution, that's right, cosecant -1 of -4 is approximately equal to -14.478 degrees. And there you go. So if you got that one right, good job. Go ahead and try number 17. And when you come back, we'll do it together. Alright, we're back. So I'm going to set that expression equal to theta. And if that's true, then by definition, secant theta is equal to 7/4. And if that's true, then by definition, cosine theta is equal to 4/7. And now we can find the measure of the angle using our calculators. So I'm going to enter that into my calculator, and we get approximately 55.15 degrees. So secant inverse of 7/4 is approximately equal to 55.15 degrees. So if you got that right, excellent. Okay, go ahead and try number 18. When you come back, we'll do it together. Alright, we're back. So I'm going to set that equal to theta, as usual. And by definition, if that's true, then cotangent theta must be equal to 5. And if that's true, then tangent theta must be equal to 1/5. And therefore we can use our calculators because we have a tangent inverse button, whereas we didn't have a cotangent inverse button. So let's enter that into our calculators. And we get 11.31 degrees. So cotangent inverse of 5 is approximately equal to 11.31 degrees. So there you go. If you got that right, perfect. Again, the reason we have to do this is because we don't have these inverse functions programmed into our calculators. And I didn't want to complicate things by giving you these types of problems in previous parts of the course. So we just kind of skipped over this, but now we're just kind of tying up loose ends. Notice that we use this inverse notation here. This notation is very confusing because it looks like we're raising something to the -1 power, and that's not correct. We're not doing that. This is just notation that means secant inverse. It's very poor notation. We shouldn't be using the notation, but it's the most popular notation. There's another type of notation that you could see, and that is this notation here. Instead of sine inverse with a -1 symbol, we have what's called arc sine. It means the exact same thing. So that is the exact same thing as this. So I'm actually going to write that down just so you know, just so you understand very clearly that those are equal. They mean the exact same thing. So arc sine √3/2 is the same thing as sine inverse √3/2. In fact, you can, instead of saying arc sine, you can say sine inverse if you want. And over here, if you see this, you can say arc sine. It's the same thing. So I just want to make that clear. You don't have to write this, but I want to make that clear. So you can just go to the next step. And maybe I'll make that purple just to differentiate. Maybe I'll make it pink. Now notice that this is a sine inverse function. So what that means is we can just use the calculator immediately, because our calculators do have sine inverse buttons on them. So we don't have to do all that stuff where we convert to a different trigonometric function as we did in the previous problems. But it says up here, look at this, without a calculator. We need to find the values of these expressions without a calculator. How can we do that? Well, do you notice that this is a recognizable ratio? It's recognizable, so this gives us an opportunity to find the value without a calculator. You can enter this into the calculator and you will find the answer, but how do you do it without using a calculator? Well, we're going to set sine inverse equal to theta, and if that's true, then sine theta is equal to √3/2. That's just a definition. There's no understanding of why that's true. There's just, you either remember it or you don't. That's the way it's defined. So you probably recognize that ratio. Obviously we're talking about a 30, 60, 90 degree triangle, and if sine is positive, then the triangles are going to be in the first and second quadrants. And sine is opposite over hypotenuse, so the hypotenuse is going to be 2x, and the opposite side is going to be x √3. You don't have to draw all of this. Okay, this is just so you know what's going on. So the reference angle is going to be 60 degrees, obviously, because the 60 degrees is always opposite the x √3 side length. And so the first angle measure is 60 degrees, and the second angle measure is this angle measure, which is 120 degrees. Now, remember, when you see an expression like this, there's only going to be one solution. It doesn't tell us to find theta between 0 and 360. if that's the case, then we would have two angles. But this angle over here, we're just going to ignore. We're going to ignore that angle because we're just finding the output of a inverse sine function. And again, you have to look at your restrictions. Sine can be between -90 and 90, so 60 degrees counts. So theta is going to be equal to 60 degrees. So what we did is we found arc sine √3/2. That's the same thing as sine inverse √3/2, which again, after all that, we found that it's equal to 60 degrees. So I know that's really complicated, and again, that's why we left it until the end of the course. I didn't want to complicate things. But yes, you do have to understand how to do these problems. Okay, so let's go to number 20. Again, arc secant -1. Well, that's just equal to sine inverse. It's the same thing. Arc secant -1 is the same thing as secant inverse -1. Same thing. And so we're going to change the form. We're going to create an equation by setting the expression equal to theta. And if that's true, if theta is really equal to secant inverse -1, then by definition secant theta is equal to -1, and we can look at our graphs. Here's our basic graphs. Here's a secant graph. Let's look for the points which have y values equal to -1, and that would be down here. That corresponds to 180 degrees. So we don't need a calculator for this problem, so we don't have to change the form of that expression, or that we don't have to change to a different function, that is. So arc secant -1 which is also equal to secant inverse -1, we discovered it's equal to 180 degrees. The outputs of the secant inverse function can be between 0 and 180, including 180. So that's why up here is 180. So it's actually touching, it should be touching that that junction there between the grid right there. So arctangent 1 is the same thing as tangent inverse 1. It's the same thing, and I'm going to set that equal to theta. And by the way, we could use our calculator to find that, but the problems tell us not to use the calculator. So I don't know how to do this. But what if I translate to an equation there? Well, now I can see that I have a recognizable ratio. That's x over x. So that's a 45, 45, 90 triangle. So I'm going to draw. And usually we have a triangle in the first quadrant and a triangle in the third quadrant when tangent is positive. But remember, when you're just trying to find the inverse tangent, the value of an inverse tangent expression, you're only going to have one solution usually. It's either going to be negative or positive. So in this case, again, theta has to be 45 degrees. You probably recognize the ratio. So we have xx and x root 2. So that must be a 45-degree angle. And that's actually going to be the answer. Theta is equal to exactly 45 degrees. So we found arc tangent 1. That's the same thing as tangent inverse 1, which we found is 45 degrees. Now again, you don't have to write all of this stuff. I'll probably be satisfied if you just write theta is equal to 45 degrees. This is just showing you what we found. So I want you to use 19 and 20 to help you do number 22, and when you come back we'll do it together. Okay, we're back. So I'm going to set theta equal to arc cosine 1/2, which is the same thing as cosine inverse 1/2. You can do it however you want to do it. You may have done it a slightly different way. That's okay. So if that's true, then by definition, cosine theta must be equal to 1/2. If that's true, then by definition, this must be true. So we can see that we're dealing with a special, we're not allowed to use a calculator. We're dealing with a special ratio. And if cosine is positive, we're going to be in the second or fourth quadrants. We can't be in the fourth quadrant because cosine inverse can't be, well, you can be sometimes, and you can be in the fourth quadrant sometimes, but not with the cosine function in this case. Cosine can be between 0 and 180. Okay, so theta is going to be, well, let's look at the side line. So the adjacent side has to be x, this side is going to be x root 3, and this side is going to be 2x. Of course, it's just a 30, 60, 90 degree triangle, and the side opposite x root 3 obviously has to be 60 degrees, so it's a 60 degree angle. And that's it, we're done. So theta must be equal to 60 degrees. But I just want to remind you that what we're really looking for is arc cosine of 1/2. That's equal to 60 degrees. That's what we tried to find. And again, you don't have to demonstrate that these are the same expressions on every step you do here. I'm just doing that so you can see exactly what's happening. So take a picture of these problems with your phone and use that to do number 23. For number 23, you may need to have these graphs because this is going to be a collapsed triangle. So get a picture of those. So try 23. When you come back, we'll do it together. Okay, we're back. So theta, I'm going to set that equal to arc cotangent 0. But remember, arc cotangent is the same thing as cotangent inverse. It's the same thing. Now, by definition, if that's true, then cotangent theta is equal to 0. Just by definition, if this is true, then this must be true also. And at this point, we have to go to our graphs. The graphs are the best thing to use when you have collapsed triangles. So look for when what are the points that have y values equal to 0? Well, that's this yellow point here and this yellow point and so on and so forth. Now if you look at the domain restrictions for the cotangent inverse function, you see the domain restriction is that the value of cotangent inverse must be between 0 and 180. So you see that this point here, where cotangent is 0, that works, 90 degrees. Again, this stuff is very confusing. Very confusing. So theta is equal to 90 degrees, which means that arc cotangent 0, which is what we were looking for from the beginning, is equal to 90 degrees. There you go. So if you got that right, good. Try number 24. Again, I know this is confusing, but that's, again, why we left it for the last part of the course. Believe it or not, you are going to have a functional knowledge of this stuff. Try 24. When you come back, we'll do it together. Okay, we're back, so we'll set that arc cosecant function equal to theta. But remember that that's just different notation. That just means cosecant inverse of negative root 2. It's the same thing. Now, if theta is equal to cosecant inverse of negative root 2, then by definition, cosecant theta is equal to negative root 2. And we can figure out what this is without a calculator. Now, normally we would convert this to 1 over sine, but we don't need to do that because we know that ratio. So we can just draw triangles. Cosecant is negative in the 4th quadrant and the 3rd quadrant, but our answers can't be in the 3rd quadrant. The domain restrictions for cosecant are between negative 90 and 90. Now, how do I know that? Well, I've got the curve memorized in my mind over here. The curve helps me to remember that it's between negative 90 and 90, the range restrictions. So the angle, well, first let's draw the side. So this side is going to be negative x. This side is x, and this side is x root 2, which means that it's a special triangle, and this angle here is negative 45 degrees. Now, why is it negative? Because our answers have to be in the 3rd or 4th quadrants. But if you rotate all the way to the 3rd quadrant, then you go out of the range restrictions. This would be an angle measured between 180 and 270. That's way out of our range restrictions. We have to be between negative 90 and 90. So we can be here or here, and obviously our triangle can't be in the 1st quadrant because cosecant is negative root 2. So that doesn't work. So it has to be in the 4th quadrant, which means we have to make a negative angle. So theta is equal to negative 45 degrees. So remember what we were trying to find. We were trying to find arc cosecant negative 45 degrees. So if you got that one right, excellent. So now we're going to deal with equations where we have a ratio that doesn't seem to be recognizable, but it turns out that we can actually solve the equation without a calculator, because even though the ratio doesn't seem to be something we recognize, if we change the form, we'll see that this equation does correspond to special angles. So I'm going to multiply both sides of the equation by root 2. And this is something that you need to be aware of throughout the trigonometry curriculum. You're going to see these ratios, and they are special ratios. They're just in a different form. So we multiply root 2 times root 2, we get root 4. And if you forgot that principle, here's the principle. Root A times root B is root AB. Now the square root of 4 is just 2, and then you see the 2's cancel out, these yellow 2's here, and we have negative 1 over root 2. So this is a recognizable ratio. That's a 45, 45, 90 degree triangle. We have x over x root 2. So theta is equal to 225 degrees and 315 degrees. So we want theta between 0 and 360. So you really need to be aware of these types of ratios. You're going to see these. Here's another example. Actually, it's the wrong problem number. Let's go down here. Here's another example. So we don't recognize that ratio, but if we multiply both sides by root 3, and by the way, if you can do this math quickly, you don't have to show every step, but we get root 9 over 3 root 3. And that becomes 3 over 3 root 3, and I think you get the point. We get negative 1 over root 3. So this is a 30, 60, 90 degree triangle. So the opposite side is x and the adjacent side is x root 3. If the opposite side is x, and that means it's going to be a 30 degree reference angle, and if tangent is negative, then we're going to have 150 degrees and 330 degrees, so second quadrant and fourth quadrant. Okay, so let's try one more of these. Again, this is not a ratio that we really recognize, but we're supposed to solve this problem without a calculator. So let's multiply both sides of the equation by root 3. And we get 2 root 9 over 3 root 3. And the square root of 9 is 3. And you can see where this is going. The 3's cancel out. And we get 2 over root 3. And again, this is a recognizable ratio. We have 2x and x root 3. So it's a 30, 60, 90 triangle. And if the opposite side is root 3, because cosecant is hypotenuse over opposite, then that means the reference angle is 60 degrees. And if cosecant is positive, then omega must be between, well, it must be 60 degrees and 120 degrees. Now, in this problem, we're supposed to find alpha between 0 and 2 pi. I forgot to do that. So we can just multiply these by pi over 180. And actually we can find exact answers. So theta is equal to 150 degrees times pi over 180 degrees. And if you simplify, we get 5 pi over 6 radians. And the other solution, again, we're going to take our degree number and multiply by pi over 180. And we're going to get 11 pi over 6 if we reduce the fraction. And when you write radian units, you don't have to write the actual unit. So, okay, I want you to take a picture of this problem here. And you can take a picture of these two problems. And I want you to try number 28. Be aware that you want to convert your angle measures to radians at the very end. So try number 28. When you come back, we'll do it together. Okay, we're back. So we're going to multiply both sides of the equation by root 2. Or both sides of the fraction by root 2, not the equation. And we get 2 root 2 over root 4. And root 4 is 2. The 2's cancel out. We get negative root 2 is equal to secant A. So this is negative x root 2 over x. That's a 45 degree 90 degree triangle. So the reference angle is 45, and if secant is negative, it's going to be in the second quadrant. So that would be 135 degrees. And the third quadrant, so that would be 225 degrees. But we need to write our angle measures in radians. So of course we're going to multiply by pi over 180 degrees. And we get 3 pi over 4. And we're going to multiply 225 degrees by pi over 180 degrees. The degrees cancel out. And we end up with 5 pi over 4. So we got that right. Excellent. Go ahead and try number 29. When you come back, we'll do it together. Okay, we're back. So we're going to multiply both sides of the fraction again by root 3 so we can find a ratio that we recognize. And we get, I'm just going to skip forward here a little bit. We get 3 over root 3. And the 3's cancel out. And we recognize this as a 30, 60, 90 triangle. And the opposite side is 1. The adjacent side is root 3. So that means we have a 30-degree reference angle. And it's negative, so we're going to be in the second and fourth quadrants again. So B is equal to 150 degrees and 330 degrees. We seem to be getting those angles a lot. So B is equal to, well, those are the actual answers. We don't have to convert to radians. So if you got that right, excellent. Okay, try one more of these problems. You're going to need to write your answer in radians. When you come back, we'll do it together. Okay, we're back. So I'm going to multiply both sides of the equation by root 2. And we get 2 over 2 root 2, which reduces to 1 over root 2. And so we recognize this ratio as a 45, 90 degree triangle. And if cosine is positive, then we can have our angle terminate in the first quadrant and the fourth quadrant. But we have to convert these to radians. So 45 degrees times pi over 180 degrees is equal to pi over 4. And 315 degrees times pi over 180 degrees is equal to 7 pi over 4. So there you go. So if you got that one right, Excellent. Again, you may have ratios that you do not recognize, and you'll have to change the form so we don't have to use a calculator. So that was the class today. If you'd like to take screenshots of all the work that we did to help you with your homework or to study for tests, go ahead and do that now. Here's a screenshot number 1 and number 2 and number 3 and number 4 and number 5 and number 6 and number 7 number 8 number 9 number 10 number 11 and number 12. But don't go before you get your homework. Here's the first screenshot for the homework. And the next screenshot. And don't go before you get the answers. Here's the answers. Remember, you must do the homework completely, correctly, and neatly, and keep it in order in your binder. So get that homework done, and I'll look forward to seeing you in the next class.